fair to say that a competitive Formula One team couldn't really operate without a strong network of technical partners. There's so many things we do where we don't have the in-house expertise to be able to develop particular solutions, where we need to look to our partners to help us out with that, and where we hope in return that we can provide an interesting development environment for their technology so that the relationship is genuinely two-way. But many areas where we couldn't put a competitive car on the grid without their help. 3D Systems are one of the technical partners we've had for many years here at Enstone. They're also one of the most strategic technical partners we have. Aero, downforce, optimizing the aerodynamic efficiency of the car. Everybody knows that's one of the really fundamental things to making a fast car. And for, I would guess, about the last 10, 12 years, a key technology in making a productive wind tunnel program is the use of rapid prototyping technology, something which 3D Systems is an absolutely unacknowledged expert in the field of. We've had a strong partnership with them for many years, where they provide us with cutting-edge machines that allow us to produce hundreds of thousands of model parts that we can put in our wind tunnels and then test the components for aerodynamic efficiency. We get the benefit of good value, leading-edge technology machines, and they get the benefit of us using those machines in anger, very hard, and really trying to push their technology to the limits of what it's capable of doing.
I'm really excited about our Lotus Renault Formula One partnership because it has been sustainable, it has withstood the test of time, it has been scalable, and together we have transformed the way that Formula One racing is done today and empowered the Lotus Renault team really to be the best that they can be on and off the racetrack. And what that means to us is the pursuit of excellence in technology and in innovation and in all of their design to manufacturing activities. Case in point, recently Lotus Renault Formula One went through a very impressive reinvestment cycle and completely refreshed their fleet of iPro 8000 production printers, which they're now using in so many activities, all the way from design to wind tunnel verification, tooling, fixturing, jigging, and all the way into on-track racing car parts. And it's exciting for us because they are showing us the way that our technology in production printers, materials, and composites is transforming the way that they think, create, and manufacture, and it shines the spotlight on other future trickle-down manufacturing opportunities that emanate from our technology. It's been an amazing partnership. It's been around now going on a decade, and it is validated again and again by our combined innovation and the kind of individual and combined investments that we're putting into this exciting field. And of course, we're rooting for our friends.
Without doubt, additive manufacturing technologies such as selective laser sintering and stereolithography will feature heavily in the future of Lotus Renault GP team. The ability to produce parts quickly and accurately have already proven themselves to be incredibly valuable assets in the wind tunnel program, and have assisted us in producing numerous parts to set geometrical iterations. What I find particularly exciting is as we move into the realms of rapid manufacturing, and that's producing parts directly for the racing car. So as we continue to develop processes and continue to develop materials to allow this to happen, it allows the designers to no longer be constrained in the ways that conventional machining processes may, meaning that parts are no longer designed to be manufacturable, because this no longer has to be the same sort of consideration, instead allowing the designer to function on the functionality. Now that's of great importance to us, because it produces potentially more efficient parts and also enhances the functionality of the part itself. All of that allows our car to remain competitive at the track. working closely in partnership with 3D Systems, we're looking to push the boundaries of the technology further and further in terms of the processes themselves or the materials that we're developing, in order that we can meet the stringent needs of the team in terms of structural performance, geometric accuracy or manufacturing rapidity, and that will all contribute to making us even more competitive at the track.
The core business of the ADM department at Lotus Renault GP manufactures test components for the wind tunnel model. Over the years, improvements of materials and equipment have expanded this from single prototypes. Initially, we started off with one-off prototypes, looking at function fit, how parts would work on the car, and general fit and function improvements. But over the years, improvements in the materials have allowed us to develop our applications both on and off the car and in the wind tunnel. This has greatly advanced the number of components we require, and has led us to develop areas that previously we couldn't do through conventional manufacturing. Digital manufacturing now has allowed us to make components that were effectively unmanufacturable in the real world, but then leads us to the problem of how we make them for the full-size car. Certain things we can help with there as well. Our relationship with 3D Systems allowed us to develop certain areas of the car which previously we were unable to hit. Certainly the quantities we're able to do now have helped us to push boundaries that before were unachievable, and every tunnel test helps to improve in production and improve performance of the vehicle. So the more tests we can do per day, then the more improvement we see on the track. Our development program with 3D Systems has been invaluable in this. We certainly wouldn't be able to manufacture the number of components at the complexity levels that we do using stereolithography at this time. Selective laser sintering has allowed us to produce test components and on-car vehicle parts for our race car. These are both used for test functions, function fit, and for actual racing. Aerodynamic improvements, small vanes, ducting, cooling ducts, scoops and fins are quite common. These allow a series of complex shapes to be made very quickly, quite cheaply, considering our small batch size, with internal details that we wouldn't be able to manufacture in a conventional manner. Certainly not in the lead times we require them. We can turn around parts in 2 days rather than 10 weeks, which is a vast improvement for us. The cost per part being relatively high if you were making 100, but if you're only making 2 or 3, the cost per part is very, very good. This enables us to take enhancements to the car and bolt them on literally the day before we go racing. We also manufacture some very complex, high-detail casting patterns for titanium parts. These allow us a quick turnaround and enable us to change the component very quickly throughout the course of the season. This is invaluable for us over the years, producing small components such as this right up to our gearbox main case with a 3-day lead time in pattern time. This again has proved invaluable, and we're literally allowed to make a change for the part per race if required.